Okay, the function f has domain 7, infinity, and is defined by that one there, right? F of x equals 1 plus 2 over the root of 3x minus 5. Find an expression for f to the minus 1 of x. So we need to find the inverse function, okay? Now, you're going to obviously start off with y equals, okay? So we change the f of x to y equals, and you have that, all right? Now, to get the inverse function, we need to get x in terms of y, so we need to get x equals. There are a few routes you can take here, okay? You know, you could do a number of options here to sort of establish how this works. I mean, what I perhaps would do here is maybe, to start with, take that 1 over the other side. So I have y minus 1 equals 2 over root 3x minus 5, okay? And then I'd be thinking, well, I want my root 3x minus 5, I really want to have that on the top, okay? That's what I'm looking for there. So we could think of taking that over the other side, all right? And of course, if you take it over the other side, I'd have to multiply, wouldn't I? Because you're dividing here, you take it over, you multiply. So when you multiply, you'd have this, wouldn't you? Yeah? I'm going to put y minus 1 in the bracket because I want to multiply all of this. You know, and take it over, I want to multiply all of it by this side. And it equals 2. Now, this looks messy, so what I will do is, because these are multiplying here, I'm going to take the y minus 1 down and divide, okay? Alright? Yeah, because I'm multiplying these two terms. I can take that term over to the side and do the opposite and divide. Right? You might have seen this in one go. You might have thought, well, I can swap these, which you can. Okay, you can do that straight away. Now it's looking a bit nicer. You've got a square root. So let's take the square root over and square the other side. And what's great is, we can do that easily. Now if you square the other side, you've got to square all of it. Okay, so you might want to do this to start with. Right? But what I would do now is actually square the top, so you get 4, and square the bottom, so you get this. That's the way I would set that out. I think it looks a bit better. Okay? And then we're almost there, aren't we? To get x equals, you have 3x equals 4y minus 1 all squared plus 5. So the minus 5 goes over, it becomes a plus 5. And then to get x on its own, of course, you need to take the 3 over, because we times them by 3. When you take it over, you need to divide, but you need to divide the whole thing by 3, right? Okay, so you could have, if you wanted, you could write all this out and put a big line and divide by 3, or you could simply say 1/3. I think that looks a bit neater. 1/3 of all of it. It's important then to have the bracket, so it's 1/3 of all of it. And then we're done. And just to finish off, then you say f to the minus 1 of x equals 1/3 4 over x minus 1 all squared plus 5. Job done. Alright? And in part B, it says, write down the domain of f to the minus 1. Okay? Write down the domain of the inverse function. Now if you think, because it's an inverse function, the domain of it will simply be the range of the original function, okay? Because the range, the output, okay, what you get with f of x is essentially the domain of this, isn't it? Yeah? Okay, that's really important there. In other words, the y values that you get out from f of x, from this here, the y values, which is f of x, these values here are what creates the domain, the input values for the inverse function. Okay, and it's important to remember that with when you're doing inverse, the domain of the original function is the range of the inverse function, and then the range of the original function is the inverse, okay, of the other function. Okay, so we've got this here, and we're going to have part B. We want to find the domain of f to the minus 1, so we're going to do that by finding a range here. So if I write that up here where it was next to it so we can see it clearly, if we're going to have 7 infinity, right, so 7 infinity is the domain of f, okay. So 7, now we'll go into this, right, we're going to put the domain in, so we're going to put 7 into it. let's see what we get. 7, 1 plus 2 over square root of 3. So we're putting 7 in. Okay, and it does include 7. So I'll get my calculator and I'll work that out. Okay, 1 plus fraction button 2 over square root. Well, 3 times 7 is 21, so I can do that, can't I? Okay, minus 5 then. So you get my answer out as 3 over 2. Okay, so that will equal 1.5. Okay, now when I put then infinity in, infinity will go to 1 plus 2 over square root of 3 times infinity minus 5. Now, it doesn't matter if you're timesing infinity by 3 and then square rooting it. At the end of the day, it's still going to be infinity. Okay, so this basically will tend to 1 plus 2 over infinity. This then will become small, it'll become nothing, okay, because 2 divided by infinity, 2 divided by a massive number is just going to be, 0. Okay, it's going to tend to 0. So ultimately, this is going to be 1 plus 0. It's going to tend to 1 plus 0, which is just 1. So there you go. There's your range of the original function. Okay, so the range will be 1 and 1.5. Okay, so now let's be careful here now, because infinity will go towards 1. Okay, so that actually will be the lowest value, won't it, in the range? Okay, and 7 then goes to 1.5. 1.5 will be the highest value in the range. The lowest value is 1, but because it's infinity, okay, it doesn't actually include it, doesn't it? We can't include infinity, so we can't include 1, so we need a round bracket, okay, like we had a round bracket up there for infinity. And then the 1.5, which we got from the 7 input, is included, okay? So then when it comes to working out the, domain of f to the minus 1, that is equal to the range of f, which is quite simply 1, 1.5. Okay?